Good evening, ladies and gentlemen. My name is Paul Stevens. I'm the current chair of BCS Nottingham and Derby. Just some apologies to start with. Unfortunately, one of our speakers has not been able to make it tonight due to a family emergency. Has had to go to the hospital. So my thoughts are with him. And we probably will arrange his session at another time. This is part of a monthly event that the branch actually holds. Normally we do this face-to-face at a local hotel, but obviously with the pandemic, we've had to change our whole method of actually doing presentations. The good thing is we hit a much bigger audience. I can see already we have far more than we normally get for a monthly event where people turn up face-to-face. But the downside is we normally have a good networking session where we have lots of questioning towards me and the committee. So when I first thought of this idea of having a joint event with CIISEC, it was back in December of last year when none of this was on our plate. And Colin Robbins, I'll let him introduce himself in a few minutes. He was willing to do this, and we, as I say, had hoped to do a joint event with 2 speakers. So Colin has kindly offered to extend his Q&A sessions as we go through the event. So Colin, over to you, please.
Okay, thank you. So I shall now attempt to show my screen. Hopefully you can see that.
I can see it, Colin.
Yeah. Although I was expecting another button there for when I do something a bit later, but we'll worry about that when I get there. So sharing, just bear with me.
While you're doing that, Colin, I'll just mention.
Okay, yeah, okay, I'm ready. Right, okay, yeah. So, well, good evening, everyone. So, yeah, my name's Colin Robbins, and I've been working alongside the BCS on this. From my perspective, I chair the local branch of the Chartered Institute of Information Security, which some of you might know from its sort of other name or previous name of the Institute of Information Security Professionals. Hold on, sorry a second, just sort my screens out. And so we normally run quarterly events, and again face-to-face, but in current times unable to do that. But we've also planned this event jointly with the British Computer Society anyway, looking at the Internet of Things. My presentation's really very much focusing on the automotive market, and so I've called it the Internet of Cars. We were then going to have a more general discussion about the Internet of Things, but sadly David can't join us this evening. So this is the agenda that I've set aside. I'm really just going to give you some context why this is the topic I'm talking about, a little bit of what the vision of the automotive market is, a little bit of balance of that with some of the history, and really this is about security, so it's how do we fix it, because you might guess when we look at history that there are some security challenges that we'll talk about, and will lead into a Q&A. Now the way this has been set up is you are all on mute, but I do want to try and take questions as we go. So the way that should work is on your control panel that there should be a little button that says raise your hand. And if you select that, my glorious assistants will enable your microphone and then give you the opportunity to raise your questions. So please do that at any point as we go. There's about 3 or 4 points in the presentation where I'll stop and pause to see if there are any questions as well. So unless we've got any questions from anyone at that point, I guess we'll dive straight in. Just looking at the chat to see if anyone's raising any questions. Okay, we'll move on then. So the context. So Nexor's been involved over the last 2 years in 2 projects funded by Innovate UK. The project on the left referred to as Capri, the name on the bottom of that strange looking pod there. And in January through March this year, another project called CavShield. So the Capri project was all about how do we take a vehicle such as a pod like that's designed for sort of local journeys, completely autonomous, and how do we go about making that road legal? And part of making it road legal is to produce a safety case, and as part of that safety case, our task was to feed in the cybersecurity case, effectively to demonstrate that cybersecurity affects, essentially attempts to hack this vehicle couldn't affect the safety of that vehicle. Learned a lot of really interesting things about what it takes to make a vehicle road legal. Sort of a quick aside, let's just put, you might notice that one of the requirements of UK law, for example, for a vehicle to be road legal is it must have windscreen wipers. And although this vehicle doesn't have windscreen, it does have a windscreen wiper, as you can see there. So that, you know, a lot of compromises in this project had to be made along that way to do strange things to enable it to become road legal. The CavShield project was then much more looking at the feasibility, having looked at some of those elements of how do you make something like this road legal, how on earth are you going to scale that out to a national scale, and how are you going to deal with the cybersecurity threats that poses. So just to make sure we're all on the same page about what we mean by autonomous vehicles, that there are lots of different scales, but this is one used by the UK government, starting from level 0, where you've got a vehicle which is driver only, up to level 5, which is where the vehicle drives itself autonomously anywhere it likes on the UK road infrastructure. If you start working your way up through those levels, you've got sort of level 1, which is where we see vehicles currently on the market today. They can automatically do some tasks like park themselves. You've then got level 2, which some of the more advanced vehicles can do, which is take control of the vehicle in a traffic jam and just keep inching the vehicle along. What you then get to is level 3, where the vehicles can, for example, do a lot of the operation themselves, but but the driver must remain alert and be ready to take control. And that's very much where some of the advanced cars, such as the Tesla, is. So whilst the Tesla can drive itself automatically on a motorway, the driver still needs to be there, ready to take over in a difficult situation. But what we're really trying to focus on here is levels 4 and 5, where the vehicle itself is in full control. The difference between level 4 and 5 being at level 4 is very much along set routes, which is very much what we were dealing with in the Capri project, whereas level 5 is very much about fully autonomous vehicles. The picture on the right here shows what's known as vehicles platooning, and I thought that's just an interesting example in its own right, because the communication between the vehicles is vehicle to vehicle. So if I'm looking at this from a security point of view and trying to run a typical model of a security operations center looking at the traffic, that's in the network traffic, that's not going to go anywhere near my security operations center. It's not connecting to any infrastructure. There are ad hoc networks that are built and taken down. So that in itself poses quite a few challenges. So final part in trying to, so I'm just make a slight adjustment on my screen here. Sorry, oops, what's gone wrong there? Bear with me. Oops. Where's my? Yeah, right. So this is the roadmap that has been put together by SYNOPSIS, who are a research organisation working very, very closely with government and largely driven by or funded by government. I certainly don't intend to go through the full complexity of this roadmap, but really, again, just to set the scene and set the context, wanted to just draw your attention to two parts to understand the scale of this. So here we have on the top right a line that puts a date of roughly 2028, 2029, the widespread and acceptable use of CAM vehicles. So CAM is cyber autonomous mobility. So this is something that the industry is thinking that within 8 to 10 years we will have widespread deployment of these type of vehicles. And as you can see, there's an awful lot of things to do before we get there. At the start, I mentioned the Cav project, and what that's been doing has been very much looking at this one small piece of the puzzle, what's referred to as the Cyber Centre of Excellence. And that's really looking at how do you go about building a centre of excellence that starts to understand all of these security issues and starts to look at how you're going to build and manage the infrastructure that's required to be able to run something on this scale. So the Cav project was very much about the feasibility of this, and as you can see, that the Cybersecurity Centre of Excellence is something that's going to hopefully run from this year for maybe about 2 years. But to give you a sort of scope of this, that's been allocated a budget of something in the order of £20 million. So there's an awful lot of government money going into making this happen. It's estimated that the implementation of this overall roadmap with both public and private money is going to be in the area of something like £4 billion. So there's an awful lot of investment required to make this happen. But for a number of reasons, that's the direction of travel, and it really is likely to happen. So that was just a very brief sort of piece of the vision of what's likely to happen. So I will just pause there briefly in case there are any questions at that point.
So, Colin, can you hear me?
Yes, I can, yeah.
Yeah, so Clinton Walker has raised his hand. I'll just release his microphone if he wants to ask you a question. Let's see if I can unmute him. Okay, Clinton, you should be able to speak.
Oh, hello. Hi guys. Hi, Colin.
Hi, Clinton. Good to hear from you.
Same here. Yes. So one of the questions I've got, I was quite looking forward to the IoT because I'm working on some projects now regarding IoT, but I'm sure it's not dissimilar to this one. But you mentioned that this doesn't go anywhere. And one of the pictures you were showing on the motorway, that when you want to like segregate, it doesn't touch anywhere near the operation center. Are you implying then that that would be managed separately as an like a security operation center separately, or it would be managed by the same team, but it's just zoned off as a separate part of the network?
So I think that's a really good question. Hopefully you can see the agenda still on the slide, and so I think that's a question that I start to address in the how do we fix it part of this presentation.
Right.
But just to give you the context of that diagram where it showed the vehicles communicating with each other, certainly yes, there is ad hoc communication between the vehicles, but there is also communications back to infrastructure as well. and there are lots of different reasons why they're going to talk to infrastructure, lots of different reasons why they'll talk to other vehicles, but they might also talk to other pieces, such as the user sitting in the car may well have their mobile phone connected. So part of the challenge here is the diversity of the connectivity that vehicle has got to cope with. And as we know from a security point of view, each one of those connections brings its own set of threats and risks. So part of the challenge here is the huge complexity and diversity in an environment we don't control, because those vehicles are out there on the public roads, connected to networks we're not necessarily in control of, and having modifications made to them by people other than the manufacturer.
Right. Okay. I've got another question on telemetry, so I'll wait until you finish that slide to look at the whole vehicle telemetry aspect as well. Okay.
Sure. Yeah. Okay. Yeah. Come back to us at the end.
Thank you.
Thanks, Clinton. There's no other questions at this time, Colin.
Okay. Well, we'll carry on. So that's kind of where we're going. I just thought it again would be worthwhile just spending a little bit time of where we come from. Don't intend to talk about any of these in huge detail, but really to say that I think it's been very, very widely publicized now, the 2015 hack of the Jeep Cherokee, where a journalist was invited to go for a ride in the Jeep, and the researchers from back in their research base, whilst the journalist was sort of enjoying his journey, managed to completely take control of the Jeep and managed to drive it into a ditch. And that received a large amount of publicity at the time. Since then, there have been similar attacks on a Nissan Leaf. And then in 2017, the widely publicized hack on the Tesla. I think the Tesla is very interesting because that was and still is widely promoted as a very good security architecture, and actually some of the things that Clinton raised about a segregated architecture. And so you can see that the guy that managed to hack it was quite a lot of wires that he had to connect to the vehicle and had to pretty much take the vehicle apart. So it was not a trivial attack as some of the others were, but nevertheless demonstrated that with the right amount of effort and motivation, it was possible to hack your Tesla. By 2018, we saw toolkits published. A lot of us on this call have come from an IT security background, and we're all used to seeing tools that are available to help us as security analysts, but also help the hackers look for weaknesses in systems and test exploits. Well, those are now available for vehicles as well. And then finally, last year, there was a report by an organization known as ADAC. For those that have not come across that organization before, it's the German equivalent of the RAC or the AA here in the UK. And they tested 237 cars and really just tested for what's remote, can they remotely unlock the doors? And in 99% of the cases, they found that yes, they could unlock the doors remotely, which is kind of interesting because that's, again, one of the big areas where we're seeing the press talk about this. And it's not that hard to use some of these electronic key measures and open the doors. But those are stories that have been around for several years now, but the manufacturers are still finding it very, very hard to address. So if those kind of issues are floating around there in door locks, again, part of the inference is, well, what else is there that's lurking? So to try and understand that, I got this slide from a company called Upstream Security, who looked at what's known as the CVE database. So that's the Common Vulnerabilities and Exposures database. It's the database where a list of anything that sort of security issues that are known in well-known products are listed, together with details of what's known about the issues, how severe they are, and whether they're exploitable or not. And at the time this slide was put together, there was a small but growing list of CVEs for vehicles, with 10 there for BMW. And I think when I looked, this is only listing some of them, when I looked in terms of doing the work for this presentation last week, I found 66 CVEs in the database relating to vehicles. So worth bearing that number 66 in mind. I'll come back to it in a few slides time. But the thing here is yeah, okay, so vehicles are now starting to understand how the security world works and starting to recognize that vulnerabilities need to be logged in these databases so that they can be tracked and managed. So just to give a final bit of context, brakes used to be simple. And here's a nice little simple diagram of what a brake looks like. You had a push rod that was linked to your brake pedal. There was some clever hydraulics. You press the brake pedal, the hydraulics kicked in, and that caused calipers to close around the rotating brake and cause the vehicle to stop or slow down. This is a slide taken from a presentation run by SYNOPSIS and ASIN, looking at what a modern braking system looks like. And as you can see, it's largely software driven. So the pedals are now not pushing a hydraulic ram, they're sensors. And there can be up to 20 different sensors now in your braking system. To make all of that work, there's a processing chain, there's storage, and there's all kind of software in there to do that. And the estimate is that there could be up to 3.5 million lines of code just to make your brakes work when you press the brake pedal. Worse than that, from a security point of view or an unknown deterministic point of view, a lot of the behavior of those braking systems is now not man-made algorithms. A lot of that is tuned and fine-tuned by using machine learning, which is again interesting that we'll come back to. So if I just think about those estimated lines of code, 3.5 million lines of code in car brakes. Just for reference, that the space shuttle that managed to fly into space was estimated at having about 1 million lines of code. If you have an Android phone, it's estimated that that's got about 12 to 15 million lines of code. And here are some other examples of your Google Chrome browser running at 22 million lines of code, and the Linux kernel at just short of 30 million lines of code. So brakes in themselves are quite not that many lines of code considering some of those other things. But if we look at the estimates of other things, so it is now estimated that Windows 10 has just shy of 50 million lines of code. But even that, and as one of the larger systems in my list there, but even that is shy of what we're now seeing estimated for the modern vehicle, which is estimated at having approximately 100 million lines of code in it. Yes, some of that will be cut down versions of operating systems, so that could account for even maybe up to half of the lines of code. But even then, there's another 50 million lines of code that are dedicated to the operation of the systems and subsystems in the vehicle. So the points to note from that is 100 million lines of code in a car, and really just looking at the relationship between Windows 10 and some of the other systems. If we then go back to my CVE database that I referenced and look at the known and published vulnerabilities. So we've got something like Google Chrome with just short of 1,000 vulnerabilities published. We've got Windows 10 with just over 1,000 vulnerabilities published. And we've got the Android phone with significantly more coming in at over 2,500 vulnerabilities published. Now, the interesting thing is not, for me, not the actual number of vulnerabilities, but the relationship between these two slides. And so the relationship between the number of lines of code and the number of vulnerabilities. And that really gives us a measure of how well we've been doing in terms of writing that code. How well have the developers followed secure development methodologies? How good has their secure by design been? How good has their testing and their sort of bug hunting been, if you like? And so on this slide, I map the lines of code to the vulnerabilities. And so just to make sure we're all following, a low number is bad, a big number is better. And so the Android phone, if you take those two numbers, roughly means that for about every 4,500 lines of code, you're going to end up with one vulnerability. Whereas actually, Microsoft as a company that 10, 15 years ago was slammed for security, have put an awful lot of work into secure development and how they improve their processes. And they've got to the stage where it takes 45,000 lines of code to have one vulnerability. So let's just assume for a moment that the developers of the software in our automated vehicles could achieve even better than that. Just to make the maths nice and easy, let's assume they could achieve a vulnerability density of 50,000 lines of code. That is, they could write 50,000 lines of code for every one vulnerability. And if we do that, we know that there's 100 million lines of code in the car. So that sort of suggests that we ought to be anticipating something in the order of 2,000 vulnerabilities in our vehicle. Go right back to where I started. So far, we've found 66 of them, because that's what's listed in the CVE database. Now, this is a crude measurement. Does it actually mean it's going to be that bad? Are there really going to be 2,000 vulnerabilities? Don't know. Have only 66 been found? Probably not, because yes, I acknowledge that some of those 100 million lines of code will be operating systems, and so some of those vulnerabilities will have been found in there. But really just use this as an example of, this is code on a scale that really is going to lead to, there are going to be a large number of vulnerabilities, and somehow or the other we're going to have to figure out how we find them all, because this isn't just a case of, oh, it's an unfortunate sort of cybersecurity attack. This is where safety of that vehicle is at stake. If those vulnerabilities are in the braking system and someone's able to exploit that and effectively mean that the car doesn't brake when it should do, we've got a very, very serious problem, particularly if that is rolled out at scale and I could amount my attack at scale. So all of a sudden, all vehicles on the road with that particular braking system suddenly had their brakes disabled. The current driving mechanisms kind of assume that if brakes are going to fail on a vehicle, they'll fail one at a time. But this kind of rollout of software, this kind of methodology, this kind of threat modeling suggests that if these vulnerabilities do exist, it could be the brakes on all vehicles using the same braking system all fail at the same time. And so the consequence of that is far more significant than obviously one car failing. So one of the findings of the CavShield problem was really saying this is a really big problem, and probably the second sentence here that's really kind of interesting is that it's likely that human teams are not going to be able to identify all of these threats. So far, human teams have managed to find 66 vulnerabilities when we can estimate there might be something like 2,000 of them lurking. So again, I'm just going to pause there in case anyone's got any questions.
Yeah, Colin,
Yep.
can you hear me?
I can indeed, yeah.
So we've got 4 questions come through. I'll read them out to you. So first one's from Nick Mellors. Which part of the UK is the Cyber Centre of Expertise based?
Yep. So that's not been defined yet. So that's very much at the stage that's been through at this stage is the feasibility studies to figure out what that cybersecurity centre of excellence will look like. And there were 4 or 5 projects that all looked at that topic. Their findings have all now been lodged with SYNOPSIS and Innovate UK, and we're expecting that to be published in May as to what their thoughts are around that. It's quite likely that it will be virtual, and so not a single location, but over 2 or 3 different locations. But there have been no decisions yet. Effectively, it comes down to the next phase, which would be a tender phase to actually start building that centre of excellence.
So Nick, you raised the question. I've released your microphone if you've got a follow-up you want to ask.
No, that's brilliant. Thank you. Apart from let's bring it to Nottinghamshire, I haven't got anything else to add.
Right, thank you. Right, next question is from Edward Arms. Cars tend to have joined media systems and driver control systems. In aircraft, these issues don't seem to be an issue. Do we need to take lessons from the aviation industry and apply their level of regulation around IT systems to cars?
I think that there's a lot of merit in that, and I would say that there's 2 things. One, I think just hold up the example of Boeing, where it's not worked quite as well as we thought it perhaps was working, and that's led to their fleet being, or particular models of planes being grounded, effectively because they started to take some shortcuts, and so we got challenges there. I think the other side of that is that, yes, if you look at what is supposed to be happening in the aviation sector, putting some of the challenges at Boeing to the side for one moment, the level of robustness that puts in there adds an awful lot to the cost of a plane. So if you put those levels of security into the generation of a vehicle, the cost of the vehicles would go up significantly, and might well put them beyond something that consumers could afford. So there is a balance here to be addressed between the robustness that you need to have something that's absolutely guaranteed secure versus something that's got an acceptable level of security. And there's an awful lot of trade-offs and thought processes that need to be given around that, particularly to determine what acceptable looks like.
Okay, Colin, some more come through. Sorry, Edward, I can't release the microphone for you for some reason. It might be because you're muted. So I'll move on to the next question from Carol Long. How much diversity is there in the workforce working on this? Most of the CEV around door locks are quoted as being a theft issue. I'd be thinking about vulnerable women driving alone. It could be a life-threatening issue with a particular person. Perspective, sorry.
Yeah, no, again, that's a very interesting question, and I'm not sure I really have the answer to that. All I can say that there was, in the projects I've been involved in, there has been both gender and ethnic diversity in those projects. I'm sure that they could do better. In terms of the types of threat, you're absolutely right that if you look at the threats that have been uncovered so far, particularly the ADAC type reports, they are very much around the physical security of the vehicle. And yes, some of the use cases around that are around the safety and whether someone could take control of a vehicle, lock the doors, and drive that vehicle off to somewhere isolated. Yeah, all of those kind of things have been start to build into the threat models. So yeah, there are lots of threat models, lots of those kinds of threats that need to be considered. And yeah, so the threat models have started to worry about some of those kind of issues. It's not just about will the vehicle brake on time. It is about, can I steal that vehicle and take control of it and do something nefarious with it.
Okay, so Carol, you're self-muted, so I can't release the mute for you. Ah, there you go. You can now speak, Carol.
I was trying to make sure I didn't speak over something else. It's more along the lines of, still the things we're talking about are about theft of property, i.e. the vehicle, or misusing the vehicle. I'm not hearing the human consequences of these vulnerabilities. And I'm sure that there must be projects going on, but I haven't heard about them yet. So I was wondering if you had. Colin, I had another question. Do I just carry on now?
Yeah, go ahead,
Yeah, your next question is next, Carol, so please carry on.
That's all right. What I was thinking about was, there's a big difference between the declared vulnerabilities and the actual issues in software, being an ex-software test manager. Microsoft got really badly stung and had 10 years to become more transparent about things and pick up best practice. And I know that they've worked really hard on their security. However, let's just say I have some family background in motor manufacturing, and I know that when things are in R&D, they've got no compunction or no history of publicising their problems and their errors. And we've seen that recently with some manufacturers with, let's just say, dissembling over results of exhaust tests.
Sure.
How do we know they're not underreporting the software errors and issues? And yes, I appreciate that there's good models, but if everyone's working to the same model and no one's really challenging it, I know from software of all sorts that you don't always pull out the errors because the testers and the developers are thinking in the same way. Yeah,
sure. No, again, those are very good questions. I will partly address some of those in my sort of next few slides on how do we address that. But you're right, and part of addressing that is, for want of a better word, of how do we keep the manufacturers honest, and so that's about providing the right level of independence in that testing. Yeah, so I think what I'll do is if I can just hold on to that question, run through the how do we fix it part of the presentation, and then perhaps come back to that at the discussion point.
That works for me.
Okay.
Thank you.
Okay.
We've got another 6 questions, Colin. I don't know if you want to answer more now, or do you want to continue for a bit longer?
Let's take 3 of them. And get halfway. Otherwise, I don't want to take all of them because we just run behind time. But let's take a few more and then hold the rest over to the end.
Okay. Interesting comparison of vulnerabilities versus LOC, but it depends on the severity of the vulnerability and its ability to exploit. Do you have a measure against critical vulnerabilities versus LOC? And that's from Anthony Harrison.
No, I think in short, no, I don't. That would be, something would be very useful to do, but no, I don't have that data at this stage.
Okay, Anthony, I don't know if you've got a follow up. I'll just release your microphone.
Yeah, you see the CVEs and you look at how many more are being reported, allegedly, because I'm sure there are people that don't report as well. And I think if you just look at the figures, they can give you a misleading view. You really need to look at the environment where that exploit is most likely to occur. So, does it require physical presence? Does it require an internet connection, etc.? And if you start putting those parameters in, you probably get a slightly different view, and potentially your 2,000 vulnerabilities based on lines of code may come down to a few, much less, and actually that helps in terms of people focusing on the testing in terms of where to actually look. because, you know, particularly when a lot of software is now used in a very, you know, generic environment, you know, whether it's on a website or in a vehicle, you know, it depends on the environment in terms of whether it's exploitable.
Yes, again, I totally agree with what you say there. I mean, it's a very crude measure that I've used there, but I think it was really used to emphasize the point that there's relatively very few vulnerabilities have been found, when we can assume there are a lot more that haven't been found at this point.
Yes,
Okay.
yeah, and actually, yeah, I remember when I started 30 years ago, one line every 200 lines of code was probably going to have a bug somewhere in it. So, you know, so in some respect, where we are is a lot better, but there's a lot more software. So, yes.
Yeah, and you're right, and it depends on those software architectures, and as you say, the opportunity that, you know, if you look at something like the Tesla, the way it's segmented its architecture, yes, you might be able to break one module, but have you got the ability to move between modules and sort of lateral movement and all those kind of things? So it's not just down to the software level, it's down to the architecture level and how well you can contain vulnerabilities.
Yeah. Okay, thank you.
Do you want to take another question, Colin?
Yeah, we take one more. Yeah, that'd be good.
Okay. How do we get some common standards across car manufacturers so we can fix loopholes? And that's from Sandeep Shajpal.
Okay, yeah, thank you for that, Sandeep. And that's the perfect question to move on to the next "how do we fix it" set of slides. So at that point, I'll move on.
Yeah, I'm just going to say.
We'll come back to that question then, if I don't fully address it.
Okay. Just before you move on, Colin, just for the audience, I'm going to be issuing some polls. It's just for you to answer some simple questions about how we've arranged this event. So, Colin, where will you?
Thank you. So, having given the context, we'll now move on to how do we fix it. So, the question there from Sandeep was about standards, and there are lots of standards, and so I will briefly mention some of them. So what I've used as my starting point is one from HMG, Her Majesty's Government. I'm sure behind that a lot of NCSC thinking's gone into this. And I'm sure a lot of you are aware the way that NCSC is going with its recommendations is very much principle based. And so HMG, but I'm sure, say, influenced by NCSC, have come up with these 8 principles for the cybersecurity for connected and autonomous vehicles. Now, I'm not going to go through all of these in detail, but I'm going to focus on some of them. So I know a lot of people on this call will be security people, and I'm sure, you know, we all know the importance of security being owned and governed and promoted at the board level. And there's absolutely nothing different here, and I'm not going to go into depths of how you might do that. But to go back to one of the questions about how seriously are motor companies taking this, they are taking it very seriously. And so, for example, ASIN, which is the Automotive Electronics Security Innovation Network, effectively a trade body working on security of vehicles, sitting on that organization, on the board level of that organization, is the chief exec of Ford UK. So the board level of automotive manufacturers do understand this, and they do understand that security has a real big impact on their vehicles. It has a safety impact on their vehicles, and if they don't address safety issues as a company, they could be in very, very serious trouble indeed. And actually, as you start to bring safety into it, it's not necessarily just the companies, but could be the individuals on the board that pick up liability. So I think they are starting to understand it. Is it universally understood? No, but some of the companies are starting to get that they need to deal with security properly. As security professionals, we all understand, a lot of what we do is driven by security risk, and there are lots and lots of different security risk methodologies. Some of them apply in this market well, some of them less well, because you've got to balance security risk methodologies with safety methodologies. A lot of things that they talk about are the same, but there are also differences as well. So again, not going to go into that in huge detail, but we know that finding a way of understanding, identifying and managing risks is going to be vital. The other part of that, say, including the supply chain, I'll come back to that in a bit. So one of the other bullets then is the security of all software is managed through its lifetime. Now we've become kind of used to this, that we identify a vulnerability, that gets reported to the software vendor, that the vendor produces a patch, we update our systems, and we keep going around that loop however many times we need to do that. With some vendors, we go around that loop every month. But we've got a bit of a challenge here that operating systems and software applications, we tend to retire them after 4 or 5, maybe, yeah, sort of 4 or 5 years. Take an Apple iPhone. Apple have typically will only support something for 4 or 5 years before they just declare we're not doing any more security updates for that. Microsoft have done the same, that you can't get your security updates for Windows 7 anymore. But here we're talking about a vehicle where typical vehicles have a lifetime of 8 to 15 years. So got a big problem here. If I've got to manage my security through its lifetime, so I've got to somehow figure out how I'm going to patch this thing in 15 years time. And so unfortunately, this kind of model just isn't going to work, because the chances are the nature of the vulnerability that I find in 15 years time, I having the processing power, the spare capacity, or whatever is needed on my 15-year-old vehicle to do that is severely limited. So that's something that the automotive manufacturers have put a lot of thought to, not least because of this supply chain issue, that maybe you need to patch software in 15 years time. Are you sure that the supply chain is going to be there in 15 years time? Is the company that provided the software for that braking system still going to be there? They might do, they might not. And if they're not, okay, maybe you've got their software through an escrow mechanism, but have you got the expertise to deal with that? And so what the car manufacturers are starting to see is that this is going to have to lead to fundamental different business models. And what we're starting to hear them talk about is one where, well, actually, you know what, I just can't, attempting to deal with patching my vehicle in 15 years time is too hard. And so new business models are being looked at where maybe I'm going to have to do a factory recall of vehicles every 5 years and build that into the business model. So that every 5 years, the vehicle has to go back to base, has a refit, has everything updated, new processors, new this, new that, and is then re-released onto the market. So, yeah, I think that's the dynamic here is that really trying to understand how to deal with some of these challenges is having to change the way we think about some of the problems. The typical software cycle of patch it until we can call it obsolete it isn't going to work because of the time frames involved here. The complexity of a vehicle is, if we've got 100,000 lines of code, it's not actually just one big lump of code. It's actually the automotive vehicle is made up of a number of systems which have a number of subsystems which have a number of devices, and it suggested that there could be as many as 150 different ECUs or loosely thinking, processors on a modern vehicle. Now, again, from a cybersecurity point of view, we're used to dealing with modules, and if we have and we have ways of black box testing them, and we have processes and standards and structures for testing them, things like common criteria, which some people put a lot by, some people don't put a lot into, but we have ways of testing these things. But again, the scale of this on a vehicle is, how do I scale that up where I've got up to 150 different ECUs on that vehicle, all combining in different subsystems, which combine to make a system, which combine to make the overall platform, because it's the security of the overall platform that I'm really worried about. And so again, a lot of research has been done into that. Just drawing an example of one project, one that I was not particularly involved with, but I think I've reviewed their work and it looks very interesting, is a project called the 5 Stars Project. And that has built up a methodology of how do you build an assurance model into the subsystems and effectively propagate that up until you can get to a level where you assess the overall vehicle by it being a combination of all of the different subsystems. One of the things that I thought was particularly interesting about this slide, though, is it's not just about the product development. It's looking about how you operate it, maintain it, decommission it. So it's talk about the full life cycle, as I mentioned on the previous slide, but also talking about cybersecurity governance and management. And this is what we're starting to see in a lot of the security standards now. It's not just about testing the product that you've built, it's how have you built cybersecurity into the way you develop the product. So into your secure development process, how are you going to manage that? So this sort of model is looking at not just the outcome, which is the software that's been produced, but how it was built, what kind of methodology that you've used, and then how have you gone about testing that, and how are you going to go and operate that and maintain it in the field. Now, one of the new standards on the block is one called ISO 21434, which is software and security standards for autonomous vehicles. And partly it follows this sort of standard, if you like, called engineering V model that looks at how do you design, develop, and validate a product, that you produce your designs, you produce your requirements, designs, and specification, you go into implementing, and then you go back up the other side, looking at how you do component and system testing. Very much along the lines of what the 5 Stars Project has been suggesting, but whereas 5 Stars is bringing that together for multiple components. But again, what ISO 21434 recognizes is that this doesn't stop at production, that this has got to also, your security has got to cover operation of the vehicle, decommissioning of the vehicle, and the supply chain as well. Having said that, there's then another project, again this time from SYNOPSIS, called the Cava Res Project, which has really said, okay, well that's all very well, but that looks at an individual vehicle. But what we're doing here is connecting that vehicle to a much more complex system. Back to my first slide, it's communicating with the environment around it. It's going to be talking to other vehicles. It's going to be talking to infrastructure. So all of those things are not necessarily within your control. The other vehicles it's talking to may be from other manufacturers, so it may have different subtleties in the way they're implemented, etc. So the complexity here is something that is far more complicated than the engineering V model can cope with. And I say this is particularly true when you're dealing with multiple vehicle scenarios. So just to give you an example of that, and we've referred to it as aggregated attacks. Here's a Google map of some roads in Germany. And again, I don't know how many people understand how Google Maps works and gets its traffic information, but effectively it's gathering information from mobile phones that have Google Maps open or are using one of the Google navigation apps. And effectively it knows where the vehicle's going, it knows where it started, where it's going, and what its planned route is. And so what the Google software is then doing is monitoring the progress of that vehicle, and if the vehicle is not traveling at the speed you would expect it to be traveling at, it kind of assumes that there's traffic, and it starts to aggregate that with reports from multiple vehicles. So this particular map was taken from a road in Germany at a particular point in time where the road had gone red, to say that there was a significant traffic jam on that road. And that was caused by this gentleman. He got as you can see, well, first of all, as you can see, there's no traffic on that road at all, whereas Google thinks it's got a massive traffic jam. What he did was he got 99 smartphones, put them in that trolley, log them all into Google Maps, so Google thought there's a lot of cars around, and then he just walked up and down that road with his trolley. And as he did so, Google Maps turned bright red saying, we've got a lot of congestion on this bit of road, that there are 99 vehicles all in a traffic jam. So that's kind of interesting, because although on my previous slides I talked about how do I go about testing an individual vehicle, and let's say that that vehicle passed all of its tests with flying colours, you could argue the same for these phones. Any one of those phones is behaving perfectly normally. It's only when you aggregate that and put all of those phones together and look at the behaviour of all of those phones, is there a problem? And this is one of the very significant problems that the Internet of Things has, and particularly the automotive market has, that a large effect of the security threats is not on a specific vehicle, and that vehicle might well be operating perfectly within tolerances. It's how that all aggregates up and behaves in as an overall system. So coming back to the 8 principles, and I'll come back to that overall system in a moment. So coming back to the principles, talked about the system needs to be designed to resilient to attacks, but it's also got to react appropriately when its defenses or sensors fail. And so part of the challenge here is, how are we going to monitor for threats at scale? And those threats come in those 2 different forms. One is where an individual vehicle is no longer operating within its tolerances, but secondly, where you now have to look at the behavior of a collection of vehicles and see if there is something going wrong within that collection of vehicles. And so, are we really able to run a SOC for that kind of thing? I think the general consensus is this is way beyond anything a SOC has ever attempted to do before. Certainly you could see a SOC that might attempt to look at the security of the infrastructure, or you could see that a particular manufacturer might be able to run a SOC and monitor the behavior of all of their vehicles. But here we're dealing with a system where you've got multiple vehicles from multiple manufacturers all driving around in the same area. So could a SOC collect data from all of those vehicles? Well, there's some interesting data protection issues there. Now that's, again, something that society is going to have to really think about, are we going to allow all of the data from all of those different vehicles to be thrown into some kind of monitoring environment. China has taken a decision on that. Not surprisingly, China has taken the view that all of the data coming off of all of the automated vehicles in China is state-owned. And so that gives them the ability to do whatever China likes doing with all that data, but also monitor for these new kinds of threats. And so coming back to a topic that I've mentioned a few times here, that this really is getting beyond the scale where you could have a SOC and a whole series of analysts looking at the SOC for threats. And I say that for two reasons. One is the scale of the threats is just likely to be too large, but also that these aren't typically threat vectors. You can't have sort of indicators of compromise because you're looking for subtle differences, such as the gentleman walking up and down the streets of Germany with his phones in a trolley. Each one of those phones was behaving perfectly acceptably. It was only when you aggregated it all together did you kind of see an odd effect. So this is where research is really starting to say that machine learning is the way forward. And so this is where, sorry, I now need to try a bit of magic, if you just bear with me. I'm just going to play, hopefully, a video. It's interesting, it's going to take itself a while. Okay, hopefully I'm back in control. So really just use that as an introduction to machine learning, and I will shortly pause for questions. I've just got two more slides to go. So at the start, I talked about the Cybersecurity Centre of Excellence, and that's partly what the proposals are saying that the Centre of Excellence will need to look at is how do we use some of the technologies such as reinforcement learning and deep machine learning to model the behaviors of these systems to start looking for those individual vehicles that within its own right is obeying all of the rules, but is in some way looking to affect the environment. So again, back to the Google car, the Google phone, 99 Google phones in that trolley. So each of those phones was compliant, but by working together, they're able to cause chaos. So the University of Bristol has done some work in this area under the Cava Shield project. And so what I've got on the screen here is two figure-of-8 loops of road. The figure-of-8 was chosen because it meant that there was only really one junction to navigate. And what you can see in both of these is on the one on the left here is there's one red vehicle. And so that is a vehicle that has used machine learning to attempt to disrupt the flow of traffic. And but it must obey the rules of the highway code in doing so. So it can't just go and sit in the middle of the junction and stop, for example. And we've got one vehicle here, the blue vehicle, which is designed to try and effectively put traffic calming measures in place to try and keep the traffic flowing across this junction. And by altering the parameters of those vehicles, you can see two very different scenarios play out. I'll play the one on the left first, whereby the traffic is generally able to flow. That you can see that the blue car it kind of slows down at the junction, but generally it is allowing the traffic to flow. So it's learned what good traffic calming behavior looks like. Whereas if I play the one on the right, the red car initially starts off going very slowly, realizes it can make a traffic jam behind it, cars have to overtake it, but it's also managed to learn that the blue vehicle is the interesting one. So it's managed to get in front of the blue vehicle, and now it's learned that, okay, I can slowly cross the junction, but not only that, once I get across the junction, even if I carry on going slowly, I'm going to block the path of that blue vehicle and cause it to have undesired behavior. So not a huge sort of revolutionary as perhaps the previous video, but really what this is demonstrating is that it's subtle changes in the behaviors of those vehicles that are important here. It's the subtle changes that demonstrate that that vehicle may have been compromised. It may be using a different algorithm set and things like that to cause some kind of disruption on the road system. And so part of the proposals going forward are to use the Cybersecurity Centre of Excellence to start using this kind of machine learning technology to look for the threats to the overall environment and the threats to the road system, and start to look at how you might be able to detect those subtle changes in behavior. Whereas, so you know, how would you be able to detect a red vehicle as opposed to a green vehicle, for example? So really, I think what that summarizes for me is where the researchers has got to on infrastructure on cyber autonomous vehicles, there's an awful lot of effort has been put into looking at the standards such as ISO 21434, looking at how you can assure a vehicle such as the 5 Stars project. But the real interesting part is a lot of that effort is focusing on an individual vehicle itself, whereas what the research is now starting to show is that compliance of an individual vehicle may well not be enough, that we've really got to look at how that vehicle behaves within the infrastructure, and obviously as part of that, then don't forget the security of the infrastructure itself. So an awful long way to go in the next 7 or 8 years before we can actually get to a situation where we can be confident that these vehicles can safely roam our streets. And that's really where I wanted to sort of finish. And so, you know, tried to highlight that, covered a broad spectrum of things, from looking at how we look at the security of an individual vehicle to looking at how that vehicle behaves as part of an overall system. And the challenges that we're going to face are unlike anything that the security industry has seen before, and challenges that industry has got to solve in the next 5 to 10 years. And you know, really question of, are we ready?
Thank you, Colin. If you're ready for some questions, we've got a few more built up in the...
Yeah, sure.
Okay, there's a couple here from Danny Holt. If I release the microphone to you, Danny, you can ask them directly if you wish.
Hear me?
Yes, we can hear you.
Yes, we can hear you, Danny. Yeah.
So my first question was, it was basically around who owns the systems. So you've got a massive amount of lines of code built up in a car. The car manufacturer doesn't own all those lines of code. They've integrated different systems to create that car. So who's responsible? Is it the system owners or the system integrators' responsibility to ensure the safety of each component?
So there's separate things there between ownership and responsibility. So yes, it's quite likely the individual component owners will own their code and be responsible for making sure that their component behaves towards behaves as per its specification. But that doesn't get over the fact that the overall vehicle manufacturer absolutely has responsibility for that vehicle. That when that vehicle or fleet of vehicles has a serious accident and it's driving in autonomous mode, it is going to be the vehicle manufacturer that the questions are going to be asked of, and they've got to be able to demonstrate that, you know, they've done everything they possibly could to have attempted to avoid that situation. So yeah, the car manufacturer can't duck that responsibility. Yes, they might delegate some of that down that supply chain in terms of, you know, that supply chain needs to provide components that meet specifications and are prepared to stand by that. But absolutely that the manufacturer has to take responsibility for their vehicle. But the other interesting part of the ownership, though, is when that's then connected to infrastructure and all of these vehicles are cooperating. That's really what I think the Cava Res project was trying to say, is we're then in an environment where no one really owns this, because we've got cars from different manufacturers all driving around the street, all talking to each other. And there's nothing there to really own because the cars are talking to themselves. So yeah, there is a really interesting sort of ownership question at that infrastructure level.
Yeah, so I suppose that last bit leads on to the next question. It's more of a philosophical question. Humans drive cars in a way that's good enough. So is it acceptable for the cars themselves to drive in a way that's good enough?
And again, I think that is a really interesting question, and I think that's again partly relates back to the aircraft question earlier of, could we put aircraft level security in, which would minimize the risks even further. I think if you look at the statistics today, that on the British roads with human-driven cars, there's something like 1,500 people killed in car accidents a year on the British roads, and harshly or otherwise, to some way or the other, society has deemed that acceptable. That that's a tolerance we're prepared to live with for the ability to use our cars. When we move to autonomous vehicles, there's going to be a number that's going to be somehow society's going to have to deem to be acceptable. I think part of the hope is that by moving to, or part of the requirement of moving to autonomous vehicles is that number will be significantly less than 1,500. But it also, by the same time, it will not be zero either. So there's a deep question for someone, and I suggest it's governments to answer, is where does that tolerance sit?
Okay, thank you.
Okay, next question's from, sorry about the pronunciation if it's incorrect, Adam Pogajolski. Are those CVEs were found in BMW, Tesla and others combined? If yes, then expect CVs will. I think what I'll do, I'll release the microphone to you, Adam. You can expand a bit. Okay, Adam.
Sorry, but my microphone is really broken, so I could only ask you with this chat. However, I wanted to ask you if this expectancy 2,000 CVs is combined from Tesla, BMW, and some others autonomous vehicles, or only from one manufacturer?
So again, that's just my sort of inference from the numbers, but the inference from the numbers is that if you've got 100 million lines of code, based on what we've seen as good so far, that would be the inference that's how many vulnerabilities you might expect in that 100 million lines of code, and so that would be the code in an individual vehicle. Now, a lot of that code will be common. We've got complex supply chains, and so there will be commonality amongst that code over all the vehicles, and so you might expect 2 or 3 different manufacturers to have 70% common code because they all get their braking system from the same third party. I mean, we've already seen that with not in cybersecurity, but in physical security. We've already seen that with airbags, that where one of the manufacturers started to see some problems with their airbags and started to recall them. It turned out that it was just one particular manufacturer of airbags that was at fault, and it turned out that particular airbag manufacturer was in 1/3 of all vehicles in the world, and so 1/3 of all vehicles in the world ended up being recalled for an update to their airbag. So again, I think we'll see that with the software side of things, that the software will be amongst multiple vehicles. And that in itself is part of the challenge here, because that also means that diversity of vehicles has the same vulnerability and the same threat. And so if I, as an attacker, can find a way of attacking that particular piece of source code, I could potentially do that to all vehicles that contain that piece of code at the same time, which is a problem that vehicles have not had to deal with before. They certainly have been able to deal with component failures, but there's kind of a random element to that an airbag might fail, but they're not all going to do it at exactly the same time.
So it's another attack vector from, for example, this third party, right?
Absolutely, it's certainly a new attack vector, and certainly that's something that it's hoped that the machine learning will start to understand is, you know, what could those scenarios look like, and how might you detect the early warning signs of those scenarios.
Okay, thank you very much.
Okay, we've got a couple of questions come up from Ian Dryden. I'll just release the microphone to you, Ian. Okay, go ahead.
Okay, good evening, Colin. Thank you for a very interesting discussion, and it's probably asked a lot more questions than we've got time to answer tonight. Previously, I was involved in trying to set the standards for aircraft, and it is a challenge because obviously we're looking at 40-year life of software and things like that. But within this, I think you started touching on it in that risk appetite and whatever. Have we actually looked at the failure mode effect analysis to sort of say, well, what are those critical things that if they fail, it's going to be catastrophic loss of life or serious injury? Because it's then that risk appetite statement that you're saying. And also, I know from the aviation industry, one thing that we have real problems with is to what level do you take your configuration management of those subsystems that you're going to be in, especially when you buy in, as you say, a brake assembly from another company?
Yeah, no, I think that there are, again, some very, very challenging questions there. Yeah, I'm not sure that I have any answers to that. Certainly the supply chain one is a really difficult one, and that's part of what's being looked at built into the assurance side of things, that if you change a component, what level of reassurance is needed. And part of what some of the proposals have been looking at is not only have you got the assurance of the vehicle at the time of manufacture, but how do you go about reassuring that vehicle during its lifetime? So at the moment in the physical world, we have an MOT that 3 years after manufacture, it kind of has to go in for a test to make sure that it's still safe, and you redo that every year. Now, what does that look like in terms of cybersecurity? Because certainly it's there's one of the real difficulties that the automotive market has to deal with, which I suspect the airline industry didn't have to deal with, is the so-called aftermarket. That under European law, I can't be tied into a manufacturer, and I certainly can't be tied into having to use their maintenance arms. And I'm perfectly entitled to modify my vehicle to add a new widget to it. And we already started to see that with, you can connect your computer to the, forget the name of it now, but there's a port you can connect your computer to, and you can get into the engine diagnostics, and you can start changing some parameters and things like that. So how do you deal with that world where the vehicle may now be operating in a way completely differently to the way the manufacturer had expected as it left the factory? And so again, there's things looking at, so how am I going to do ongoing vulnerability assessment of that vehicle? Certainly doing an annual MOT type test, it just isn't going to be frequently enough. So what frequency does that testing need to be, and what does that testing look like? At the very minimum, it would be some kind of vulnerability assessment of, are you running the latest software on everything in that car?
And added to that, the complication's going to be, initially, you're going to have legacy vehicles and Cava Series 1, and then a few years later, Series 2, Series 3. Yep. So actually, that's going to really make it complicated.
Yes, yeah, totally agree. And again, I think that's why the thought processes are that this complexity is beyond what standard mechanisms that we've got for dealing with this can cope with.
Okay, thank you.
Colin, we've got about another half a dozen questions. Do you want to take a short breather and I'll do them polls? Or do you
Yeah,
want to
that'd be good. Yeah.
Okay, sorry about the interruption with the poll earlier. I didn't realise it was going to stamp all over the screen. So I'm just going to issue the next one. If you could answer the simple question. I'll launch it now. Thank you. I'll just close that one. And the final one. This is just to help us see how effective our advertising is in terms of events and what channels we use. Thank you very much. Okay, Colin, you ready for your next question?
Yeah, sure.
Right. This is from Mark Smith Roberts. So I'll just release the microphone to you, Mark. Okay.
Hi, good evening. A question really reaching back to one of the first slides you showed about the various levels of autonomy for the vehicles. And then if you were to consider operational security and using AI, ML to do a constant stare analysis, if you like, on the vulnerabilities and the risks going on with that platform in the network in which it sits, is it the objective that if a threat or risk, emerges, that you close that platform down, or is it possible you could have graduated reduction of autonomy? So, for example, if you're in a, if everything's hunky-dory, AI/ML is saying low level of risk, it's good on our impact levels, it's good on our risk appetite, we're going to give you maximum level of autonomy. But then if uncertainty comes in, could you pare it back and introduce the driver as a mitigation for some of the risks? So where are we? Are we sort of trying to be dynamic in our design, or are we going for an old-fashioned platform accreditation? If it doesn't tick all the boxes, it's not going on the road.
Again, I don't think all of those questions have been fully answered. Certainly looking at aspects of that, vehicles at level 4 and level 5 autonomy, where the vehicle is driving itself, backing off the autonomy and handing over to the human driver is unlikely, because the designs of those vehicles are such that there isn't a steering wheel, or any of the other controls that a driver would need. So right at the start, I had the picture of that Capri pod. If that was unable to operate in its level 4 mode, it just wouldn't be able to operate. There is nothing in there that a human could take control of, which is sort of one aspect of that. The part of a lot of what's been looked at is exactly what do you do when a issue has been found, and that to some extent already happens within a vehicle, in terms of a vehicle in the physical world has a set of diagnostics, and so if it detects something that's wrong that says, okay, I'm kind of safe for the moment, but you need to deal with this, it puts an orange light on your dashboard. Whereas if it's a serious problem and you really need to bring this vehicle to a safe halt as soon as you can, it puts a red light on your dashboard. So that kind of graded behavior is sort of already built into the system, and so certainly the research I've seen is the manufacturers are kind of looking at that kind of graded system of, yeah, no, this is absolutely a red issue, and we need to bring this vehicle to a safe halt as soon as we can, versus this is an orange issue, which is, you know, I'm going to have to alert the garage that there's a problem here, and but I don't have to stop the vehicle immediately. Also related to that are what I talked about in terms of vulnerability scanning. When is it safe to do your vulnerability scanning? Now, it's assumed a lot of these vehicles will be electric, and so one of the thought processes some of the manufacturers are looking at is, okay, maybe I can actually run a vulnerability scan when it's charged in at the electric point, because I know it's safe. And if I then find any vulnerabilities, I just don't let the vehicle restart until they've been dealt with. So it's partly about when do you find the problem, and partly about how severe that problem is. The other part that I think is just worth mentioning is one of the questions earlier was about the human aspects of this. And certainly, I'm pretty sure it's University of Oxford have done some really interesting research in this area that looks at, if you take the Tesla model, where the Tesla can drive the vehicle for you know, at level 3 autonomy and do the simple stuff, but when it gets complicated, hand control back to you as the user. What the research has shown is that because you're not driving that car all the time in normal times, you're actually becoming de-skilled, and you've forgotten how, and you're not forgotten, but you're not practicing your skills at all times. So when control is handed back to you for the difficult situation, you're actually de-skilled and less able to cope with that. So again, there's some really interesting dynamics there as to you know, is handing back to the human a safe thing to do, because we may no longer have the skills to deal with that.
Any follow-up? Otherwise, I'll move on to the
back on it. Just your points about the vulnerability analysis is an interesting one. I mean, that's where personal belief, I think we've got to go through a generation change with cyber. Is yes, we know what the vulnerabilities of the platform are, perhaps at some stage, but you have to take risks in some platforms or some systems. And you know, if you can be out there and you know there's a vulnerability, but it's, you know, likelihood is low, or you know, for whatever reason there's other mitigations available to you, but then you detect when that exploit has appeared somewhere in the in the network somewhere, that's when you take the measure. And I think I'm looking for that. That's the dynamism, I think, which we need to, in the time frame you're talking about for these vehicles coming to the street. You know, there's going to be an awful lot of development in this field, and I just wonder where, you know, who's looking at that kind of dynamism, or, you know, analysis, if you like, in order to manage our risks, as opposed to completely mitigate them from the start. That's just I guess an open piece. You don't need to answer, but it's just an area of interest.
Yeah, no, I agree, and I think that there's two parts to that though. There's you're absolutely right. There's what's the impact of that vulnerability on that individual vehicle, and what's the likelihood of that occurring. Therefore, is that individual vehicle safe? And that's, if you like, traditional cybersecurity type risk assessment of, is that vehicle likely to be safe? But there's also the aggregated effect that what, you know, if all vehicles had that same vulnerability and they all had a very low likelihood and a low impact, but if I, as a threat actor, could do something in the infrastructure to trigger that threat on all vehicles at the same time, that's another vector that I've got to throw into my risk assessment now.
Okay. Any more to follow up, or shall we move on to the next question? Okay, got another one from Edward Arms. I'll just release the microphone. You're self-muted, Edward. Okay, I'll read it out. It is, does the threat model include looking to defend against rogue external control devices, i.e. malicious input from a compromised overhead sign?
I think the short answer is yes. I mean, the threat models have to cope with all of those kind of things, and that part of the difficulty here is understanding what all of those different threats might be, and the scale of those. So yes, absolutely, it does. But that's also where, again, machine learning is kind of being looked at as something that may well help here. But yeah, sort of rogue information from signage that, you know, it's certainly in the autonomous vision, some of that signage may no longer be needed, but instead the roadside infrastructure would be communicating to the vehicles whatever the instruction was, such as the mandatory speed limit or anything like that. And yet there's absolutely the chance that signage, that infrastructure itself could be providing false information. And that's really why I think my last slide was, don't forget the infrastructure, because right now most of the research has looked at the vehicles. It's just started to look at the aggregated effect of vehicles, but I don't think anything has really started to look at what's special in the infrastructure. Is this just normal infrastructure that in theory we know how to secure, but our track record's not brilliant on, or is this even more complicated? So yeah, you're right. The threat model's absolutely got to cope with all of this.
Yeah, that's perfect. There's nothing else from me on that.
Thank you.
Okay, thank you, Edward. Got a question from Nick Mellors, but it says from Jay Mellors, would the standards look at data security when a vehicle changes ownership?
I'm sure that they will have to, and there's again different. There's a lot of data ownership questions in that market at the moment, and there are sort of, if you like, two types of data. There's certainly the personal data that you've customized your vehicle, you've connected your mobile phone to it, and you've downloaded your address book to it, and all those kind of things. And there's been some very interesting security attacks that have been done, for example, on hire cars, where you managed to download information related to the previous person in the vehicle. So there's those kind of data ownership, and absolutely that's something that vehicle manufacturers are going to have to get better at, particularly when vehicles are likely to be multiple use. I mean, some of the models of the vehicles are, you know, it's unlikely that we're going to own vehicles in the same way that we own vehicles. I think the statistics are that if you take the ownership model that we have at the moment, a typical vehicle is being driven for 2 to 3% of its lifetime. The other 97% of the time, it's parked up outside your house or your place of work. Whereas when we move to autonomous vehicles, it's expected there would be a lot more sharing going on. You might be renting your vehicle out whilst it's not doing something for you. And I think, you know, some of the models are looking at, we might actually get up to sort of 20% occupancy of the vehicle. And so at that point, I've got, again, a lot of more interesting data sharing going on in that vehicle. I mean, the vehicle knows things about you. I certainly know that you know, some government departments are very concerned about some of that. For example, you know, some of the more secure sites, the vehicle knows an awful lot about you. It knows that you work at a secure site because you use its car park every day, and it knows the route home that you take, and it knows where you live, which is, for, I say, some of the government agencies, that in itself is a concern. So there's certainly elements of that privacy side of things that needs to be taken care of. The other side of that coin is, sorry, and I should just add at that point, in the US, they're taking that very seriously, and there is an act called, not surprisingly, being America, the US Spy Car Act, which is actually putting obligations on manufacturers to protect the privacy of owners' data, amongst a lot of other things as well. But there's also a lot of other information in the vehicle, and there's still a lot of debate as to who owns some of that vehicle. So again, coming back to my braking system example, the brakes generate an awful lot of data about the vehicle. And there's a big ownership question of, well, who owns that data? The brake manufacturer or the vehicle manufacturer, or you as the driver? And again, I'm not sure that those are necessarily fully resolved.
Okay, just by the way, if you've got any questions towards me and the committee, just put them in the chat, especially if you've got any ideas or suggestions towards future events. Colin, well, we're getting towards the end of the number of people asking questions. There's a number come through from Manuel. What I'll do, Manuel, I'll release the microphone to you. I'm just finding it. Okay, you can speak, Manuel.
Hi.
Hello. Hello.
Can you hear me? Okay.
Yes, I can.
Thank you. First of all, I'm from Spain, so sorry for my English or for my French. Hi, Colin. I have been writing that, but I can't say it for myself. Now, thank you. I was kind of horrified on automated vehicles security and its risks. Then you talked about how to fix that, and it relieved me a little. However, on the topic about industry security, I have some worries because you say the security challenges are unlike anything we have faced before. And I was wondering to me that the security can be mischievous and mischievous a person wants to be. And then if we add machine learning, AI, and so on, so it could be even worse. So if people are kind, safe, and well served as customers by the industry, of course the industry will go well. And even so, if the person who as a customer has no power, cannot do nothing to be harmful to the industry. But on another hand, for example, I can imagine a South African kid, a child, one child, who has mastered AA and programming and so on, who didn't receive his Bitcoin from an enterprise or for someone who is working in an enterprise, or who didn't receive the last product or the last iPhone that even the parent ordered for him as a gift that costs like 600 euros or dollars. It can become from a minor, no serious risk to whichever level you could imagine of harmful to the industry. So what could it be done? What we could do? What it could be done on that matter? Thank you beforehand.
Sure. Yeah, I certainly agree. I mean, that there are lots of challenges and that needs to be overcome. So certainly, you know, machine learning does offer an avenue, but you're absolutely right that machine learning and AI in itself represents a potential threat. So that's something that has also got to be taken care of. As you saw in the video, that machine learning is kind of based on the rules that it's trained with, and so an awful lot of the security in this environment will have to be based on how is that AI trained, and how do we know that it's trained by the good guys, etc. And yes, so that is certainly a set of issues and threats that were identified and are known about. How you deal with them is not my area of expertise, but it's certainly, yeah, as part of the broad spectrum of topics that will need to be answered. But that doesn't just apply to autonomous vehicles either, that we're seeing AI being much more involved in general security as well. So certainly the security of AI is a topic that I'm sure that the research community will be looking at considerably over the next few years.
Yeah, I agree with you. I only believe that security should be a matter that maybe is necessary to prove or to experience on it before to develop the AI, machine learning, and whichever we can imagine, or to put someone into a vehicle, into a car that is not is autonomous, so it can be controlled from outside and could be a risk for the people, the customers.
Yeah, I think that I certainly understand what you're saying is that there are risks there. I think that the flip side of the coin is, if we don't use machine learning, what are the alternatives? Because what we've shown is that there are huge scalability problems here, and the complexity is significantly more than anything that we've dealt with before. So our track record as an industry in security is not great. We still keep seeing data breaches on websites, and so if we can't get some of the simple things right in some of those simple environments, how are we going to deal with something on this kind of scale, with this kind of, it's not just the scale but potential impact as well?
I have been just the last one. I have been developing a kind of an scale before, when I was listening. That is quite similar to the University of Bristol. That is could be directly applied on autonomous vehicle as a solution, or maybe a kind of solution or a principle. Maybe could be a key, or maybe could be a development, I don't know. But it's based on a machine learning against another machine learning. One is attacking, but not one time. It's continuously attacking the system of the vehicle or the car, and or the car or whatever, and another machine learning that is learning and continuously refreshing that system. So it's being attacked from one side for a machine learning, and another machine learning that is controlled in a vicious or a cycle vicious cycle. No, it's called. It's like a continuous cycle on this being attacked from one side and being protected for the other side, and learning how to protect better. So it could be a closed system that in the meantime is working. Nobody can attack because it's working, it's refreshing continuously.
Sure. Yeah, no, I understand what you're saying. So I think that's called sort of the adversarial machine learning approach. And as I understand it, I mean, if you take Google, the Google car that drives around in California, that they've certainly used that sort of adversarial machine learning to try and train its behavior. And as I understand it, I don't understand the actual numbers, but the ratios are for every hour that the car has been driven, there has been 50 hours in the simulator using machine learning driven.
Thank you.
So it's certainly a technique that's being used. Yeah. Okay, Paul, is there any other questions, Paul?
There are, but a lot of people have left, Colin, and I think
we have run over time. Yeah. Yeah, I mean, do we want to call it a day there? I mean, we've otherwise, I know a lot of people have, because this was the sort of the length of, we were expecting to go for 2 hours, weren't we? I know I've hogged the whole time,
Yeah.
but
No, it's okay. I think we're coming to the end. So just for everyone's benefit, I've just put a link into the chat for BCS Nottingham and Derby's next event, which should occur on the 18th of May. I think John Mitchell, the speaker, is in the audience. So I will release the microphone to you, John, if you wish to introduce yourself. If you can hear us, John. If not, I'll just announce what the title is, which is Designing InfoSec Controls. The booking is on the site. This session will attempt to lift the veil on the mystery surrounding the simple statement, this system lacks adequate control. So let's say, if you follow the link in the chat, you should be able to find out some more details. If there's any questions, as I say, towards myself and the committee, the BCS Nottingham and Derby committee, in terms of future events, then please put them in the chat. Colin, I can open the mic generally if there's any questions for anyone who wants to raise a question, but I don't know how well that will work with so many people in the call. So if you want to ask a question,
yeah, it's pretty best to carry on through the chat mechanism, isn't it? I think.
I've released the microphone should people want to ask a verbal question. Okay, it seems that there's someone coming in.
Yeah. Okay. Well, all seems to have gone quite. So I put sort of the final slide up. It's got if you do have any further questions, you've got the email address there, info@nexo.com. If you want to fire me a question, just put seminar or webinar, BCS webinar in the subject line, send it to that address, and it will find its way to me.
Okay, Colin, thank you very much for doing a very good presentation. I know we wanted to do this face to face with some tea, coffee, and biscuits, but you know, this is world events have overtaken us. Colin and I are looking to do a joint event in the autumn. Hopefully, it might be either a combination of physical and virtual, but we'll have to see where we are by the time we get to the autumn. But thank you, Colin. That's really great.
Thank you.
Okay, I'm going to close the event now. So thank you very much for all of you who have attended, and stay safe.
Thank you. Thanks, Paul. Colin, thank you.